Here are some notes on nuclear notation. A couple things to recognize the notation is that at the very top, this is our mass number. At the bottom, we have the atomic number. This is also that number of protons. Now just a hint, on the periodic table, you may not be given this bottom number, and the notation could look as this. We have 37 and then the chlorine. The reason is the periodic table is available and you can find this information on the table. Now in the next two examples, we have one more number that's very important. This is the charge. And this is the difference between nuclear notation and hyphen notation. Nuclear has a place for the charge. When we have a charged particle, we're going to call it an ion. And when there is no charge, this is our atom. So, two names that we also need to remember when we have an ion is we can have a negative ion, which is an anion, or a negative ion. And then we have what's called a cation. For a cation, remember a positive sign's a plus, very similar to the T in the middle of the name. Now the charge is based on the protons and an electron balance. So if there is no charge, that means that protons and electrons are equal. If there is a positive charge, that means we have a loss of electrons, and so there will be more protons than electrons. No, protons cannot change, only electrons can to give us the charge. If it is negative, we have a gaining of electrons. So therefore, we will have more electrons than protons. Again, protons can't change, only electrons can for the charge. For this example of nuclear notation, we are going to use what's called a cation or a positive ion. We find that it's a positive ion because right here, this charge is a +2. Starting off, taking a look on our periodic table, we find magnesium. Its atomic number is 12. And because the atomic number is 12, that also means the number of protons is 12. On the periodic table, we also find 24.31 is our average atomic mass. Remember, when using the average atomic mass, that you need a gram per mole as the unit. In order to find the other ones, we need to know what the mass number is, and it is given right here on the top of our nuclear notation. 23 is the mass number. Again, this will always be a whole number. And it helps us find our neutrons because mass number minus my proton will equal the number of neutrons. 23 minus 12 gives us 11. The charge is that 2+, which will help us find our electrons. Now here, this means that we have lost electrons. We know that because it is positive. We know 2 electrons were lost because of the 2. So our electron amount would be 10. Another way to find it is to take your protons minus electrons to find the charge. So the problem would set up 12 minus x equals 2. For Lewis dot, because there's a charge, there's a slight change in how we draw it. You're going to bring down the symbol, and because we lost electrons, there are no dots to draw. But to show it's different from an atom, we're going to place it in brackets and put the charge on the outside corner. For valence electrons, it matches the dots that we draw. Since we did not draw any, there are no valence electrons, so 0 is our answer.